My name is Deandrea. Just a little bit about me. I've been doing open source software for 20-something years. I've been at Red Hat. I'm just finishing off my 4th year. I've been a contributor to a lot of different open source projects, mainly Spring. I've done a lot of work in Spring over my career, not as much recently, but in a previous life. I am a current contributor to Quarkus. I'm not on the engineering staff. However, I'm just one of those who has a passion for open source and likes to contribute to stuff. I've also written a book. We'll talk about that in a little bit. Recently, my most recent talk, if you don't know me that well, I kind of have a passion for testing and talking about different things in relationship to testing. So I partnered up with Holly Cummins last month at DevOps Belgium, and we did a talk about testing pitfalls with microservices and contract testing and whatnot. So if you're interested in that, there's a link down the bottom. I will share the slide deck with the organizers after the fact, so they can distribute it to whoever. So you don't have to feverishly write down to take notes and whatnot. So let's get going. So what are we going to talk about today? So we'll do a quick intro to Quarkus. We'll talk specifically about looking at Quarkus through the lens of a Spring developer. I know myself personally, whenever I learn something new, it's always compare and contrast to things you already know. And so for me, when I was learning Quarkus a couple of years ago, I would compare and contrast it to Spring because that's what I was familiar with. So I have some tips, some tricks, some techniques, a lot of common questions I get when I talk about it that people have asked me that I've kind of conglomerated into this presentation. Got a bunch of some extra resources, some Q&A, and there is a hands-on part of this. If you're interested, we certainly won't have time for it tonight, but if you want to, as a takeaway and want to do it on your own time, there's a hands-on workshop. It'll probably take you an hour and a half to do if you want, and I'll provide the link and QR codes and stuff for that. So if we kind of take a step back and think about what's the problem Java was trying to solve in general. We didn't just decide, hey, we need yet another Java framework out there just for the sake of having a new shiny Java framework. So the challenges that we're trying to solve are kind of been exacerbated as from where Java has been in its last 25, 26, 27 years. Back in the day, you'd have these applications or application servers, which you didn't really care how much space they took or how long they took to start, because they were doing these huge long-running workloads that ran for days, weeks, or even months at a time. Whereas now, if you think about where we're going with the advent of containers and Kubernetes and whatnot, we tend to build smaller applications that the resources that those applications use are far more important, right? So before if we needed something to be faster, we'd throw more hardware at it. We'd buy bigger machines, give it more memory. But that's not really so much the case anymore. The more memory you throw at it, it's not necessarily a linear cost. If you look at like AWS instance sizes, for example, doubling the memory is going to cost you more than double the cost of that instance. So we try to solve the scaling problem by scaling things horizontally, which means we need things that are going to start up faster and use less resources. And Java is kind of a perfect example from that, because as you start up a Java application, there's a few seconds that it takes to just start up, and the JVM does a whole bunch of stuff at startup to initialize and start things up and whatnot. But then the JVM itself gets really smart over time. It figures out what your application is actually trying to do, and will optimize the bytecode at runtime based on the code paths that are executed. So we call this the warm-up effect. And the warm-up effect for a median-sized application could take an hour, 2 hours, or something like that. It takes time for the JVM to watch what's going on within the application to figure out what it's what it needs to do and how it needs to do it. So there's a link to a talk at the bottom of that if you want to know more about, the just-in-time compiler warm up right now. The first 13 minutes of that talk is actually pretty excellent. It was a talk that was done by someone from Azul at DevOps Belgium this year. Very, very interesting talk. So if you're interested to learn more about that, you can. I apologize, I need a sip of water. And it's not really specific to any particular Java framework, right? It's just kind of the price you pay for Java in general. But when you look at it on something like Kubernetes, for example, it becomes really much more important. Because if you take an example, and this is actually a true story from one of Red Hat's customers, where what they were seeing is they had an application that the normal state for the app was something like 700. I'm going to make it round number, 700 requests per second, and one instance of their application could do 800 requests per second before it would need to scale horizontally to serve increased load. So, but what they were seeing was as traffic increased to something like 14 or 1500 requests per second, Kubernetes would then start to scale up their application. But the problem was the application, as it started to scale, it still wasn't warm enough to deliver on what its SLA was because it needed time to warm up. And what Kubernetes started to do under the covers was say, hey, this application is not meeting my SLA, let me start another one. And then let me start another one. So the Kubernetes would start to scale out to like 5-6 instances of the application. None of the applications were really running at peak capacity, but it still hadn't warmed up enough to be able to satisfy the load. And then at the end of once the time passed, when the load went away, Kubernetes would just start killing off these pods because they weren't needed anymore. But the applications themselves were never really utilized to their full potential. And so what they started to see is their costs were, kind of going up through the roof because of all this kind of, they called it wasted compute, right? They used all this compute resource and all these memory resources for really no apparent reason. And while all that was going on, they still weren't meeting their SLA. And so that's when they started investigating something like Quarkus. And that's kind of the main challenge as to why Quarkus came to be where it is today, looking at that resource utilization challenge. So we needed something and we needed a new stack to be able to build applications to solve the challenges that we need, that we have today. Excuse me. If you think about what does a typical Java framework do at run or in general, you've got the separation between build and runtime, and traditionally build time is just that, build, compile, and package your artifact, and push it to Nexus or Refactoring or whatever. And then at runtime, the JVM starts it up, reads your config files, does a bunch of class path scanning, starts thread pools, and all that kind of stuff. But what Quarkus tries to do is flip that model kind of on its head. So if you think about, I'm going to scale these applications horizontally, that warm-up period that you're going to do, like that could take an hour. Well, if it's the same instance of the same application, why should you have to pay that penalty each and every time? Why can't we pre-warm the just-in-time compiler at build time while still allowing some runtime flexibility? And that's what Quarkus tries to do. And it's also kind of important too, if you build your own and what I like to call like a meta framework. So in my past experience, we used to build our own custom Spring Boot starters on top of the published Spring Boot starters that implemented all the opinions that we had within our own organization. So something like that, if you're doing something like that, you kind of need to take a step back and rethink what it is you're doing, because depending on what you're doing and how it does it, you want to take advantage of this build time versus runtime separation. So, as an example, we had one customer where they were kind of piloting Quarkus and they had these custom Spring Boot starters, and they just kind of re-implemented the starters as Quarkus runtime dependencies, and they saw their memory footprint go through the roof. Well, that's because in Spring, when it starts up, is doing all this like class loading and class path scanning and whatnot. So it's loading all the metadata of all the classes anyway. So the fact that your custom code is doing this annotation scanning and whatnot is almost like penalty free because Spring has already loaded all those classes for you. But in something like Quarkus is doing that at build time, and it's warming that into the just-in-time compiler. So if at runtime, if your own custom code then starts doing all this reflection and metadata stuff, now you're paying a penalty that your application wasn't paying before because Quarkus had already optimized it for you. So you kind of like double, you're doing it at runtime when Quarkus has already done it at compile time. So you kind of need to rethink about how you're going to do stuff like that, kind of what we would call the Quarkus way as a Quarkus extension. Thinking about what can be done at build time and warmed at build time versus what needs to be left at runtime. Things like connection pool sizes, database URLs, URLs in general, credentials. Obviously, all that stuff's got to get left to runtime. You're not going to bake that into your application at build time. And what's kind of interesting is, and I don't mean to diminish this at all, but the fact that you can build this native executable, and I'll touch on what native is in a minute, but the fact that I can build a native executable is almost like a side effect of the design of the framework in the first place, right? The whole build time model of optimization and pre-warming and whatnot, just, the output of that can be, a jar, which I run on the JVM, or a native image that's compiled to native bytecode. It was a design goal from the onset versus something that had to be retrofitted into something that pre-existed. And I'll come back to native in a minute. Another key feature that we saw out there, as this whole reactive programming model and reactive manifesto and whatnot was coming to be a few years ago, was reactive programming is really hard. I can kind of see people in the room who's done reactive programming. I'll get my binoculars out and look to see if I can see hands. I see, is that one hand in the back, two hands in the back there? So reactive programming is hard to do. Quarkus under the covers is based on a reactive engine, but that doesn't mean you need to write reactive code. You can continue on writing blocking code all you'd like, and Quarkus will be perfectly happy to do it and manage the worker threads for you and move your work off to worker threads. You don't need to make that choice up front like in other frameworks. So like in Spring, for example, you kind of need, before you've written a line of code, need to decide, am I going to do like Spring MVC, or am I going to do Webflux? And, am I going to do thread per request, or am I going to do event loop? But Quarkus doesn't really care what you do. You can even mix and match in the same classes, and Quarkus will just figure it out. Doesn't really matter. And then one key piece that that's actually really hard to measure is developer productivity. How quickly, a new sprint comes in, or a new story or whatever that you're working on as a developer, how fast can you be productive to implement something, to test something, to go through what we would call your inner loop development cycle, code, compile, test, run, iterate, and then until I'm sure it works, and then I commit it to Git or whatever version control you're using, and then move on to the next thing. Things like, hey, my application doesn't necessarily live in isolation by itself. It's got a database or a message broker or an OpenID Connect server, or, whatever it is that the application needs. Being able for Quarkus to understand what your dependency is, and not just pre-configured for you, but actually spin one up if you didn't provide one. So if I'm doing something that needs a database, for example, when I run my local development environment, Quarkus will just say, hey, it looks like you've got a Postgres driver. Why don't I go out and grab a Postgres container image and spin it up and bind it to your app while you're working? And by the way, while you're working, you don't have to restart the server every time. I'll recompile your changes on the fly and run your tests as you're typing and as you're doing it, and give you immediate feedback to what you're doing. So all this developer productivity stuff, kind of in air quotes here. But at the end of the day, it's still Java. So all the same stuff you're already using, Hibernate or Kafka or Prometheus or Micrometer, Cassandra, and you name it, stuff that you're already using today. You don't have to learn a whole new thing to do it. And so I'll talk a little bit about any questions so far, I guess, before we move on to native compilation. Nope. Okay. So native compilation. So GraalVM is this thing that's, everybody's excited about right now. And I'll talk a little bit more about my opinions on it. But GraalVM is this thing right now, which is out there, which allows you to take application code and compile it down into native machine binaries. And GraalVM is not just for Java. It can do other languages as well. And Red Hat is a part of that. Red Hat contributes to that. The Java Flight Recorder and the ARM image support for that was contributed by Red Hat. But what's interesting is the Quarkus test suite is actually part of the GraalVM test suite. So when GraalVM goes to do run their TCK or whatever, building and testing against Quarkus is something that they test against. But we also have, because GraalVM has all this extra stuff for compiling other things in other languages, Red Hat tries to make it easy by providing a kind of I don't want to say scaled down version, but a distribution of GraalVM that's really kind of specific to Quarkus. It kind of strips out all the guts of the stuff that it doesn't need and makes it work really, really good and really, really fast for Quarkus, with focusing only on Java. So it's pretty much just a drop-in replacement for GraalVM. You can run GraalVM CE, you can switch it to manual, and no big deal. But like I kind of alluded to, I have my opinions on GraalVM, and I think my opinions are shared by people in industry as well. So GraalVM is kind of like, or native image in general is this, I kind of like that silver bullet that's kind of flying through the sky right now, and everybody's chasing it and say, hey, I want to do native image. I want to do native image. And I almost compare it to like Kafka was a few years ago. Everybody was saying, oh, I want to do Kafka. I want to do Kafka, even if it's not the right use case for what you're trying to do. So native image is a really good thing, and it is really good for certain use cases, but it's not an end-all be-all for all use cases. I would venture to say probably 75% of use cases, you're probably better off in JVM mode than in native image. And this isn't just with Quarkus, this is with any native technology. Spring Boot native is coming in next week or the week after. I'd say the same thing to that. Native compilation isn't the best solution for everything. And there's a few reasons why. One, the developer joy aspect of it. GraalVM is not equivalent to developer joy. If you've tried to build a native image before, it takes a huge amount of RAM, like 6, 7, 8 gigs of RAM. Even with Quarkus is pretty optimized, and still 6, 7 gigs of RAM just to do a native image build. And it can take minutes. Luckily, I've got a fast machine. I can do it in about a minute. But when I had my old machine up earlier this year, it could take 8-9 minutes to do a build. Monitoring tools isn't interesting. So if you're doing agent-based monitoring, like things like Dynatrace or whatnot, you're gonna have to find a different solution for your native image because your application isn't a Java application anymore. Throughput is interesting because you would think native image is super fast. It'll just outperform everything. That's not really the case. Over time and under heavy load, their application running on the JVM will probably actually outperform a native application. Sure, the native application will start up faster and will use less memory, but over time, the JVM will be able to serve more requests per second and be able to process more requests under max load. And again, that's not just with Quarkus, that's with any kind of native technology. The JVM is going to give you better throughput over time. So there's really not a single answer as to which one you want to use. I always recommend just start with the JVM, see how it works for you. If you've got a really use case, some of the use cases, I've got an edge device, or I've got devices with limited amounts of resources. Well, then native is probably a good use case. If I need super, super fast startup times, like in a serverless environment, Lambda or Azure Function or whatever, native is probably a good choice for that. Things that are shorter lived, it's going to start up, it's going to do something, then it's going to go away, and I want it to use as little resources as possible. Native is a great choice for that. But for things that are run for long periods of time, you're probably better off on the JVM. Some things just in general that Quarkus probably isn't a good fit for, thick client, if anybody's doing like Swing or SWT or any of those types of things, Quarkus certainly isn't the best choice for that. I don't even think it supports it. Mobile device apps, if you're doing like Android apps or whatever, probably not a good fit. Firmware or super constrained embedded devices and systems, probably not a good fit. Heavy image, if you're doing like image and video processing, probably not the best thing to use. I would probably say Java is not the best thing to use in general for that kind of use case. Any questions so far? That's kind of the intro to Quarkus. No. Excuse me one second. I need a drink. All right, so let's talk a little bit about why we're here, Quarkus for Spring developers. So this talk came out of a book that I wrote last year. Not last year, it came out the end of last year. And I say people always tease that when you write a book, the minute it's published, it's completely irrelevant, right? Because technology changes so fast. And I certainly agree with that. But I would say that the concepts and the examples and whatnot that are in here are still very relevant. I've actually kept up. There's a repository of examples behind this out on GitHub that I've kept up to date, so long as I didn't have to change the code in the book. So as new versions of Spring and Quarkus have come out, I've been constantly updating the examples. But looking at Quarkus through examples, and Spring has all of its different conventions and whatnot. Some are more tribal knowledge than others. Like if I name this class this and I put it in this package, then things just kind of magically start working. Things like that. Looking at that for someone who's familiar with like Spring MVC, Spring Webflux, Spring Data JPA, Spring Cloud Stream, Spring Integration, and then some of the newer cloud stuff. Looking at how you might do that in Spring, and then looking for examples of doing the same thing in Quarkus, and not just building the applications. As I kind of alluded to at the beginning of the talk, I kind of have a passion for testing. So looking at how you might test those things, both in Spring and in Quarkus. And what you'll find, and you want to go through the demos and whatnot, is it's someone who knows Spring, who has never heard of or looked at Quarkus, is probably going to be able to pick it up pretty fast. There's not a whole lot of differences. And if I had to say one thing that in the book that's changed probably the most since it was published was the last chapter on like cloud and like service binding and Kubernetes. I mean, that space has moved so fast in the last year that I would say that chapter is probably the thing that's changed the most. So it's a free download. I don't make any money. It's not for sale. It's a free resource. So if you haven't already and want to take a look, feel free. So some things as I've been doing different talks and I've talked to a lot of people that are doing Spring or know Spring or have contributed to Spring, and some kind of common questions that I typically get. The first one I've kind of alluded to already. Can I do reactive or imperative or blocking or non-blocking? Whatever you want to call it. The biggest difference here is with Spring, you kind of need to make that decision up front before you've written any code, whether you're going to do the event loop or the thread per request model, with either Spring MVC or Spring Webflux. And not only that, it affects how you're going to test your applications, right? I think recently with Spring, you can start to use like web test client with Spring MVC endpoints, but even still, the libraries that you choose up front impact pretty much everything else within your application. Whereas with something with Quarkus, I could do a fully reactive application, but I could still use Hibernate in a blocking fashion, and it would work just fine. Or I could do, have one method. I could do fully reactive down to the database and have one little thing that needs to be blocking, and it's perfectly fine and it's pretty easy to do. So I don't really need to make that choice at all, really, until something drives me one way or another. The whole should I do reactive or should I do blocking? That's a completely different conversation. There's whether you're going to do one versus the other, and I'll come back to reactive programming is hard, and if you're not familiar with it, it's not necessarily all that intuitive all the time. the next question I get all the time is, what if there isn't an extension for my library? And in Quarkus, an extension is, thinking and comparing to Spring, like a Spring Boot starter. But the difference is an extension has two parts to it. The extension has what's called a deployment module, which is the stuff that happens at build time. Like I want to create beans and inject beans and warm the just-in-time compiler and generate some bytecode. That part happens at build time. And then there's the runtime part of the extension, which is like, if your extension needs to offer configuration to, for URLs or whatever, things that are going to happen at, when the application is actually running. And so the classic use case here is something like Lombok, as, just to throw out an example, Lombok or the Apache Commons, or, you name it. There's a bunch of libraries out there that people commonly use. Mapstruct is another one. Generally speaking, just throwing it in your dependencies, you're going to be fine in JVM mode. The question comes about native, depending on what the library is and what the library does. If the library uses a ton of reflection, then there's probably some stuff you're going to have to do to get it to work in native mode. But if it doesn't, like Lombok, I know as an example, works fine in native. Mapstruct works fine in native, no problem whatsoever. Excuse me. Can I reuse my existing Spring code is an interesting question. And the answer is it depends. So there's like code that's specific to Spring, and then there's code in your application that's not necessarily tied to Spring, but it may be, maybe it's a method that has some business logic or something in it. Pretty absolutely, you could reuse the business logic for the most part. The stuff that kind of is tied to Spring, like the typical examples are like the Spring MVC, like all the annotations which map URI paths to your methods, or the bean injection or Spring Data JPA code, the kind of the scaffolding and the wiring. Quarkus has a set of extensions for Spring compatibility. So things like, auto-wired annotation, or the Spring MVC annotations, or Spring Data JPA interfaces and annotations, Spring Data REST, Spring Security, the cache abstraction, the configuration properties, the scheduling stuff, and the config client. If you're using a config server, Quarkus has some compatibility extensions that we call them for those. But my kind of word of caution with using them is they're meant to be a compile time adapter. They basically, at compile time, they say, oh, this looks like a Spring MVC controller class. Let me, at build time, rewrite that as a JAX-RS class using REST-easy reactive under the covers. And so at runtime, your application is not a Spring application anymore. And the problem people start to run into, they think, oh, I'll just use these extensions and I'll build my app as if it were a Spring app, and it'll just run under Quarkus, in air quotes here, and everything will be good. But the problem is it doesn't track every Spring feature one for one. So if you're doing like really complicated things, and the example I typically use is like in the REST world, if you're using, I don't remember the name of the class, but there's a REST exception mapper class that has a bunch of protected methods on it for, customizing the payload under different conditions, like 400 errors or whatnot. That class doesn't exist in there. The application context class itself doesn't exist. The import annotation doesn't exist in there. So it's not meant to be a full-fledged, replacement for Spring. It's meant to just kind of help you get your feet wet. Maybe you're not doing something complicated and you can take advantage and you don't have to rewrite a lot of code, and start to migrate slowly over time. Talking about migrating, I get a lot of questions about, hey, my application uses these Spring Boot starters. What are the matching Quarkus extensions? And that is totally not the right way to go about doing it. The right way would be looking at what capabilities does your application provide? Like, are you doing REST? Are you using Postgres? Are you using, a Hibernate wrapper, or are you talking to Kafka? Whatever it is whatever capabilities your applications are doing, then go look at what's the Quarkus way to do that, not just what dependency can I swap to get the functionality. And because sometimes, and as you've seen, I'm going to do a demo in a minute, and my demo is a little trivial, so that I can do it in the time allotted. And I'm just going to do some dependency swapping and very minimal code change. But in reality, that's probably not going to work most of the time. Another question I get a lot is, how stable is it? People look at, issues on GitHub, and I think it's kind of a crap metric in general. Just kind of like same way as GitHub stars is, I don't really know or necessarily agree with that, because a project has so many GitHub stars that it's better than another project. Just me. But getting back to the issue thing, I went out the end of September, so these numbers might be a little off. But as of the end of September, I went out and I looked at Quarkus. It had 1,956 issues and 108 pull requests. Okay. So I went over to Spring. Well, the first thing you got to figure out is, what, Spring is so broken up. You've got the framework, then you've got Spring Boot, and then you've got Spring Security, and you've got Spring Cloud. And even within Spring Cloud, you've got all these different sub-projects. Then you get into Spring Data. So trying to find out exactly how many issues and pull requests are open, just as an example, Spring Framework had almost 3,400 at that point in time. So trying to correlate number of issues to how stable something is in general, to me isn't a very good metric. And then, a lot of times, and I think Spring does this too, not just because something is in an air quotes here, an issue, doesn't necessarily mean it's a problem, right? Teams use issues as like epics or for planning or to ask questions. Doesn't necessarily mean that there's a problem per se. Another question I get is that when I try to compile with GraalVM, it's memory intensive and takes time. And I shake my head and I say, yes, that is true. That is a very true statement. Is there a question? Right? Because it's just the nature of what it is. It gets better. GraalVM has matured over the last year and a half, no, even more than that. It's been more than 3 years, because Quarkus has been around for 3 years and has supported native compilation since day one. But GraalVM itself has gotten a whole lot better over the last 3 years, to the point where it's still not great. Yes, it's memory intensive. So if you're going to do it, you need to kind of figure out within your organization how you want to operationalize it. Because you probably, if you're doing builds on your pull requests and whatnot, it's probably not something you want to do on every pull request build, right? To do a native compilation. I kind of touched on this other one too, like the meta framework thing. I think I talked about that a little bit earlier. If you do have, or you do your own custom starters, or you have your applications kind of do their own springy stuff, at startup, you probably want to think about what it is that you're doing and how you're doing it, and take into consideration what could I actually do at build time to help pre-warm the JVM versus what needs to be left at runtime. Because sometimes, like I said, just leaving it to runtime, you might actually see worse performance, because where Spring was already doing it for you, at runtime, and giving you, making your memory usage that much higher, Quarkus has already kind of optimized that for you. This is kind of an interesting, this was actually just published yesterday. So we've been looking at, not me personally, we Red Hat, and actually Holly Cummins was the one who did this. So if you're interested in the full talk, there's a whole hour talk behind this that she did at the Dublin JUG a couple of weeks ago, and the link is down the bottom there if you want to go watch it. But looking at the cost and carbon impact, writing, are my applications green applications? How can I reduce the carbon footprint of my Java applications? And we actually did an experiment where we looked at setting up a few instances in AWS with a 99% uptime SLA and hitting it with 800 requests per second over a 20-day period, which would essentially equated out to about 50% load. And looking at, well, what would the cost be, and how would we measure the carbon? How they measure the carbon impact, I can't tell you that. You'd have to go watch the talk for them to explain how they measure the carbon impact of that. But the findings were that Quarkus compared to, and they called it Framework A, they used Spring, that saved 2 to 3 times the amount of carbon for the same workload given the same load. And it reduced the cost by 2 to 3 times, because they were able to use smaller instance types and still have wiggle room, per se, for extra load if it needed to burst. So I thought this was pretty interesting. Like I said, it was just published yesterday. There's a white paper out on the Red Hat site, and then you can actually watch Holly do this talk that she did at the Dublin JUG a couple weeks ago. There's some tooling if you want help. If you say, hey, I've got this Spring application and I want to, what might that look like, or how would I migrate that to Quarkus? There's a free tool out there. My word of caution with it is it tries to be as least invasive to your code as possible, which means it tries to get you to use those Spring compatibility extensions, which, like I said, that's not necessarily a bad thing. Using the compatibility extensions, but if I were to build an application from scratch, I wouldn't use them. It's not their intention. But this would give you a good kind of rule of thumb. Give you a story point estimation as to what in your code needs to change. What you might need to investigate. Is there a Quarkus thing which can do what you're doing, or do you need to look at other solutions for that? So, I mean, like in technology, nothing is perfect, but it's definitely a good start. All right, with that, I think I'm going to move off to demo unless there are any questions. Are there any questions? I can see the people in the room, but they're literally like a box like this, so I have to get a binoculars out to see anybody here. No? All right. So what I'm going to do is I'm going to go over to my favorite IDE, IntelliJ. What IDE you use is completely up to you. But this is the GitHub repository from my book. So there's, the top level repo, there's a bunch of chapters, and there's projects for each chapter. And I'm in the chapter 4, which is the persistence chapter. And I'm looking at Spring Data JPA. So it's a simple Spring MVC application, which uses Spring Data JPA, talks to a database. I'll show you the code here. So there's a properties file, just sets up the data source. It looks for a local Postgres database. It sets up Hibernate to create and drop. There's some data. It's a very, very complicated database schema, as you can see. It's got 3 fields in it, got some rows that I'll insert. It's got the application class. It's got a domain object. It's got a JPA entity class. It's got the ID. It's got a name. It's got a description. It's got a bunch of getters and setters. People have asked me, well, why don't you use Lombok? And I'm not a fan of Lombok. Lombok and I don't really get along very well. So I do not like or use Lombok. I'd prefer to have my getters and setters under my own control. Thank you very much. I've got a Spring Data JPA repository class I add an extra method to be able to find a fruit by name. And then there's a Spring MVC controller class. Pretty standard, nothing out of the ordinary here. It has a method which returns all the fruits, has a method which returns a fruit by name, returns a 404 if it doesn't find it. And then there's a method for adding a fruit to it. And then there's a bunch of tests. So under the covers for testing, if you haven't heard of test containers is a wonderful library that can spin up containers for you on the fly. So at test time, I have a separate configuration which uses this little special URL. So when I run, like I do it right now, if I just run Maven verify while I talk here, it'll actually spin up a Postgres container for me on the fly. And run the tests against using the container, and then shut the container down when it's done. It's got a bunch of tests for testing the Spring Data JPA, and then it's got some tests that use mock MVC and Mockito for mocking. I'm a big mocking fan, and it tests the repository, tests the REST layer while mocking out the repository layer. Using mock MVC. So pretty standard stuff in here. So the first thing I'm going to do is I'm going to start a Docker container for our database. So when I run the application, now I'm going to run the application. I'm using Java 17. I'll start the app. So started, and one thing that's kind of interesting that I'm going to keep track of while we go is some startup times and whatnot. So I know it's not an exact science, but taking what the framework reports as its startup time, which to me isn't the best metric. The better metric would be time to first request, but I don't have an easy way to do it. I have a script that'll do it for me, but for what we're going to do, as long as we do it the same way every time, I think we're okay. So I'm going to start to say, so for Spring Boot on the JVM, the startup, I know it's tiny, let me make this bigger. Time was 2.78 seconds. And then if I go back, so I'm going to just issue a few HTTP requests. I get all the fruits, great, want some JSON. I'm going to ask for an apple, get the apple. I ask for a pineapple, get a 404 because it doesn't exist. I also have in here, I've got a JSON file, which has like the JSON structure for a fruit. So what I'm going to do is I'm going to post that so that it adds the fruit. And then if I issue the HTTP again, there's a third fruit there. And if I ask for the pineapple, it's there now. Great. It's super complicated application. But what I can do is I have a script which can go through and look at the resident set size of the application. So resident set size is both on heap and off heap memory usage for the application. And so in this case, it's 287,008. And I do that into 1024, about 280.2. So 280.2 megabytes. So that's how much memory that this application is taking up right now. So by the way, this is actually using Spring Boot 2.7.5. I do have they had that native experimental stuff in the POM XML. So in the POM, I have a profile for native, so I can actually build a native image with Spring Boot 2. So let's go ahead and do that. You can do maybe clean package and just activate the native profile. And I have GraalVM actually installed on my machine here. And this might take, I think the last time I tried it took 2 minutes or so. I also have on another branch, and I can switch to it when this is done, I actually have the Spring Boot 3 RC2. I have the same application coded with that. The only difference from a code perspective is the change for like in the domain model, like the javax.persistence has moved with Spring 6 to the Jakarta EE package. So it's Jakarta.persistence. And similarly with like the Java Beans validation spec. So there's a couple code changes that had to go along with it. But we can come back to the Spring Boot 3 version of this once we're done here. And I am on a Mac M1. So compilation times are pretty quick for the most part. This used to be very painful on my old Intel Mac. Excuse me. And similarly, once this is done, the GraalVM compiler is going to give us some metrics. It's going to tell us how long it took, what the size of the binary was, and how much RSS the build process actually took. And we're going to translate that over here. JVM startup time. So under native, build time, build RSS, binary size, and then we have the application startup time, full record, and the application RSS. All right, so 2 minutes and 6 seconds. It took 2 minutes, 6 seconds. It's RSS. We make this a little bigger. The build process took 7.3 gigabytes. 3 GB, and the binary size is 106.31. So now, once that's done, I'm gonna kill the database and restart a new instance, because the application will create the schema, and so I wanted to actually create the schema, not connect to a database that already has the schema. But now if I run the application, you can see it's up and using the same metric, 0.208. 208 seconds. Again, not the perfect metric. The better metric would be time to first request, but that's a little harder to measure without some automation and some scripting in place. And then I'll just do the same kind of requests that I did before. Look for the fruits, look for an apple, it's there. Look for a pineapple, it's not there. If I add the pineapple, and then get the fruits again and ask for pineapple again. Oops. And then if I look at the RSS again, so 136, 528 into 1024, 133.3. So we've made our application start up a whole lot faster, close to a power of 10, and we've cut our memory usage in half by doing native. So that's cool. All right, so let's start this. So now we're going to go in and we're going to do some surgery. My handwriting is terrible. My parents always said I was going to be a doctor, so doing surgery is great. I see a question, what JVM? I'm using Java 17. Yep, 10 year in 17.0.5. All right, so what I'm going to do here in the POM is I'm going to get rid of a bunch of stuff here. I'm going to get rid of all that. I'm going to get rid of the parent POM. I'm going to get rid of some properties. I'm going to get rid of the dependency management section, and I'm going to fill it in with some new stuff. And so rather than have to watch me type everything, I've kind of pre-scripted it a little bit. So I've got some new properties for versions, and because I'm not a Spring app anymore. I've got the new dependency management sections that will bring in the Quarkus bill of materials with all of its versions and whatnot. And so now, I know this is kind of like I said before, don't go dependency by dependency. Look at what your application does, but I'm going to exactly go dependency by dependency, right? Even though I said not to. So I'm going to change this dependency to io.quarkus, and I'm going to copy that because I'm going to paste that a lot. And so this is going to be the Quarkus Spring Boot Spring Data JPA dependency. All right, then now I've got the Spring Starter Web, so I'll swap this one for the Quarkus Spring Web dependency. And then I also have to add the Quarkus REST-easy reactive extension. So under the covers, Quarkus is based on, I think I mentioned this, is based on a reactive engine. So REST-easy reactive being the implementation of that, regardless of if you're writing reactive code or not, that's the engine you want to use. It's the fastest and most performant one. So the Spring Boot Starter validation, again, I'm going to swap that to the Quarkus Hibernate validator. And then we've got the Spring Boot Starter actuator. So I'm going to swap that for the SmallRye health extension. So SmallRye is an implementation of the microprofile specification. The microprofile specification has things like health checks and whatnot, which is what the actuator was doing. So it's not a direct one-for-one because the actuator has other stuff in it too, but we really only used it or cared about it for the health checking. The other thing I need, because I'm using YAML, I'm a big fan of using YAML for my application configuration. So I need to add the Quarkus config YAML extension so that it knows how to do YAML. And now I get to the Postgres driver. So instead of the raw Postgres driver, I'm going to, again, swap that with the Quarkus JDBC Postgres extension. And then I get into some of my test stuff. So instead of Spring Boot Starter test, I'm going to swap that for the Quarkus, JUnit 5. And then I also need, because we're doing some mocking and stuff with Mockito, I need if I could type right, Quarkus JUnit 5 Mockito extension. I can get rid of all this test containers stuff. Like I said, I don't need it. Quarkus Dev, and I'll talk about dev services in a minute, but when you run Quarkus in its development mode, it embeds test containers and it will use test containers to automatically spin stuff up, and you'll see that in a second. CertJ, so where the Spring Boot bill of materials manages the version of a CertJ for you. Quarkus bill of materials does not, so you need to tell it which version. And then the last dependency I need is Rest Assured, which is the library that we use for testing RESTful endpoints, which is something you could use with Spring as well. It's not a Quarkus specific thing. It's an open source. This needs to be a test dependency. I think that's it. And then the last part I need is the build plugins. And so I'll throw in all the build plugins. So there's like the compiler plugin and the Quarkus Maven plugin and whatnot. So now that I've done some surgery, let's go to my terminal here. And the first thing I'm doing, I'm not even going to start the database. The first thing I'm going to do is I'm going to say Maven clean Quarkus devs. And so I'm going to run Quarkus. And you notice I haven't touched any code. I haven't touched a line of code. And it fails because I have this class here, this application class, and it doesn't know what to do with it. So this is kind of like my favorite part, right? I'm going to just start deleting stuff. Eliminating code is a great feeling. So I'm going to go through. I'm going to delete this class. Boom, gone. There's a corresponding test class that goes with it. Gone. And then there's also this application YAML that's in the test package. Don't need that either. Gone. All right. So now let's do this again. Clean Quarkus Dev. So we got some exception here, but if you notice what that exception is, it's a compilation failure. It can't compile the test classes, which that's all right. We'll get back to that in a minute. So, but the application is actually up and running in what Quarkus calls its development mode. So to prove that, I can run the same HTTP requests, right? And boom, I'm getting data. I can run fruits, apple. It's up, but I'm not running a database manually. Quarkus just said, hey, looks like you're, the magic is right here. It says this dev services for the default data source. It's like, hey, I see that you've got a data source defined. You haven't configured it. Let me go grab a Postgres container and spin it up for you automatically. The other kind of cool thing that I'm going to do is I'm going to turn on what's called the continuous testing. So I'm going to push the R key, and it's going to go and it's going to tell me I couldn't find any tests. Well, that kind of makes sense because it just told us that it couldn't compile any of the tests, right? So if I go to my actual test class, let me clean up some of this mess here that I've got. So I go to we'll start at my repository test. Obviously it doesn't know what this is. So, okay, so let's say instead of at Spring Boot test, we'll call it at Quarkus test. It's still transactional. What transactional on a test means, if you're not familiar, that if you're using a real database or an in-memory database or something, even with Spring, it'll run each test in an isolated transaction, and then it'll roll the transaction back when the test is complete. So that's done. I can just hit save. Oh, and continuous testing picked up. It found my test and it's running my test. That test now passes. So now let's go to my control work test. This one will need a little bit more surgery than the last one. So I can say at Quarkus test, this mock MVC thing, we don't need it, gone. So we're mocking our repository class. So instead of mock bean, I can say inject mock. That's good. But now we got to kind of convert mock MVC to rest assured, which is actually pretty easy. So I'm going to do kind of some global search and replace over the entire class because there's a bunch of tests here. So I'm just going to replace all of that. This will be a dot. Then I'm going to do some imports. Rest assured. And we'll say dot status code. I'll call it a 200. Content type is JSON. And now I've got this that I've got a global source. So instead of dot and expect, I'm just going to say dot body, place all. And then instead of this, I'm just going to put a comma instead. And then get rid of that, and get rid of that. Oops, I did one too many things that I shouldn't have. So and then we'll call it is. There we go, that's what I forgot. And then this little is function comes from the handpress matchers, which is what Rest Assured uses under the covers for its matching. So now I can remove that exception, copy paste that. And then this one, then call it 404. Move the don't need throws exception. And the last one here is this post. So the post is a little bit more complicated. So I can say given content type of JSON with a body, and I'm just going to copy this body string. When I do a post to /fruits, then it's not hash code, then I have the same expectations as above, 200 and JSON. So now if I save, now it runs all my test pass. So a little bit of refactoring, but if you notice, what I didn't touch was the mocking. So I didn't touch at all any of the mocking. All I did a conversion from Spring, from mock MVC to Rest Assured, but in the repository, I didn't touch anything, really. I didn't touch the test. I didn't touch the mocking. All I did was changed it from a Spring Boot test to a Quarkus test, and now all my tests pass and everything's working. I didn't touch any of the other code at all. Excuse me. All right, so the last piece of this that I got to do is in my application configuration, it still has the Spring configuration. So let's add some Quarkus configuration instead. So when my application is not running, so the dev mode that I talked about or showed will automatically spin up the containers and bind everything to it. And that's great for when I'm kind of doing my quick inner loop cycles and whatnot. But once I've kind of built my application and I've thrown it over the wall and I want to actually run it somewhere, I kind of need to tell my application where the database is, right? It's just not Quarkus isn't that magical. So what I'm going to do is I'm going to come back, I'm going to start up my database container. And now I'm going to just say java-jar target. We got to compile it first. Don't want to run the tests. I got to package it because dev mode doesn't actually package. It does kind of its own thing behind the scenes. Now I can say java-jar, and I can start the app up. So again, we'll go with this not the best metric in the world, this 1.173 seconds. Quarkus, so JVM, setup time, what did I say it was? 1.173. And so now let's hit it a few times. Fruits, ask for the apple, it's there. Ask for a pineapple, it's not there, I'll add it. Now it's there. If I ask for it again, now it's there. So now if I look at the RSS, So 157024 into 1024, 153.3. 153.3. So the RSS of the Quarkus on JVM is not much higher than the Spring native RSS. And it's significantly, it's not half, but it's significantly smaller than the Spring Boot. And I know I've run the same experiment with the, we may not have time, but I'll kind of talk about it. I've run the same experiment with the Spring Boot 3 RC2. And the Spring Boot RC2 is actually, the native compilation is slower, uses more memory, and is bigger, both in JVM and in native, than its 275 counterpart. So that's kind of cool. So let's do native compilation. So if I do native, how does this stack up? So while that's going, native, so build time, build RSS, binary size, startup time, and the RSS. So this should be significantly faster. Excuse me. So while this is going, I'm going to apologize to everybody. It's still the middle of the day for me. My kids are going to get home in about 5 minutes, and they've been warned, do not come in here, but the dog is going to start going. I got a little yappy dog, and it's going to start going in about 5 minutes. All right, done. Minute 12. Minute 12, the build RSS 6.66. The binary size is 64.09. And now let's run it. Let's start the database. Oops. Up 0.119, 0.119 seconds. And let's use it. Oops. Apple, ask for a pineapple. Not there. I'll add it. Oops. And now if we do the RSS, 62704 into 1024, 61.2. 61.2. So we're well under half the amount of memory, a whole lot faster than native. Quarkus on the JVM, again, its memory usage is almost on par with the Spring native. Its startup time is significantly smaller than Spring Boot. I could go on. I mean, I know we're starting to run out of time. I could convert this further to folder Quarkus. You could actually see what that looks like. It takes about 10 minutes or so. The numbers don't really change, like the compile times and memory usages. It's really no change at all. But I think I'll come back. We'll finish this off, and then we'll take some questions and whatnot. Any questions about the demo part? Nope. Okay. So just some extra resources for you. So if you aren't familiar with it, Spring has its pet clinic for its sample application to learn about, how to do stuff in Spring or whatnot. Quarkus has the superheroes, which is a microservices-based set of applications for showcasing different things that Quarkus can do. There's some reactive, there's some non-reactive, there's Mongo, there's Postgres, there's Kafka, there's Avro, there's OpenTelemetry, there's WebSockets, there's lots of stuff in there. It's a good place to go if you want to learn, to play with, to see how things are done. And there's lots of tests, from someone who likes testing. There's also there's a workshop that you could organize. It's not public facing, but through Red Hat, you could organize if you're interested, where you get hands-on. I think it's a half a day, excuse me, where you take the Spring Pet Clinic application and convert it to Quarkus and then break it out into different microservices. There's some other stuff, some additional resources, but then there's also a bunch of user stories. So people, different customers who have gone through the journey. So, it's always better when someone else speaks for you. There's lots of customers. If you just go out to Quarkus.io, there's a bunch of user stories out there that have talked about their, where they were, why they chose Quarkus. There was a recent one too. It's not on the list here, but DataStax, actually, just their Stargate API platform, just kind of decided to go all in on Quarkus with that. But there's also IDC did a study. They call it Framework A. It actually is spraying under the covers, talking about the different benefits and whatnot. Like I mentioned at the beginning, there's a hands-on part of this. If you want to do it, it's kind of almost like what I just went through, except you're using that tool that I talked about earlier, that migration toolkit, to analyze the application and to do the migration. But it's not the same application, but it's a similar application, similar setup with Spring MVC and Spring Data JPA and Open API and all of that kind of stuff. And then there's a QR code and a link. It's just a project out of GitHub, and the instructions are right in the README out on GitHub. And that's all I got.